Hello everyone, welcome. Today we are working on one-step equations. This is page 6 in your notes. And at the top under topic it says inverse operations, and I apologize, that is a typo. Inverse operations was the other page. This is solving one-step equations. So we're going to write one-step equations at the top. That way when you see this page, you know this is where we're solving one-step equations. Go ahead and fill in today's date and our essential question. Our essential question today is, how do I solve one-step equations? How do I solve one-step equations? Go ahead, take a moment to write this down. Those of you that are using your own paper, you might want to take a moment to write down all of these sentence frames as well. This is going to be our step-by-step process to follow. So we're going to pause, take a moment, write down your essential question, fill in the date, and if you are not using the note packet with us, take a minute to fill in these sentence frames so that when we go take our notes, you can stay with us. Alrighty, so we are ready to go now. We're going to work on solving one-step equations. Now here's what I want you to know right up front. There are several of you that when you look at these equations, you can figure the answer out in your head without showing any work on paper, without doing much work. You know the answers. And that is fantastic. However, we are going to get to the point where there's some harder questions, bigger numbers, negatives, decimals, fractions, and while it may not seem like it now, we are going to get to the point where you might not be able to do it in your head, and if you are moving too quickly and trying to only do work in your head, you're going to make mistakes. So one of the main things we are focusing on today is the idea about having a variable inside of an equation and solving for what that variable has to equal. And we're also working on how to organize our work. How can we show our work so that when we get to really complicated problems, we know what to do. We know the steps to follow because the steps stay the same even when the problem gets complicated. And today we're just working with one step. So we're going to start with one step, then we're going to move into two step, and we're going to move along there. So let's take a look at this equation. So we are working with these equations down here. This is 7 times x equals 21. You may already know some facts in your head that tell you what number times 7 is equal to 21. When we're working on this, we are trying to figure out, what is this x value? What number does this x represent? And while we might know this in our head, we still want to show our work to solve it, because again, we're going to get to complicated problems. So we're going to take a look at this. When we are working with 7 times x, when we're solving equations, we're going to be working backwards. We're going to be utilizing our inverse operations, our fact families, where we could start with our number and do opposite operations to undo the math that occurred on the other side. So step by step, the first thing we're going to do is identify the operation. Identify the operation. Okay. That means we need to identify the operation that is being used. The big question that you will hear me say a lot is, what is happening? Before you get to solving anything, before you get to doing any work, what is happening? One big thing to remember, you're going to see it a lot. In fact, I'm going to change this problem here because we don't usually use this division sign. We use a fraction bar or a fraction line. A fraction is a division symbol. And we're going to get to that when we get down here. So on this first one here, we said this was 7 times x. So when I say what is happening, you would say, well, 7's being multiplied by x. The next thing we do is we need to identify the inverse operation. Inverse operation. How do we undo that? Inverse operation. The question here is, how do I undo the operation? How do I undo what's happening? I want x by itself. I want this to say x equals. So multiplication, the way to undo multiplication, the inverse operation, is division. So we're going to divide. And remember, like we said up above, a fraction bar is division. So while I could use a division sign here, I'm typically going to use a fraction bar. And I want to divide by 7. What is 7 divided by 7? Yeah, 7 divided by 7 is 1. So when I have 7x divided by 7, I am left with 1 times x, or just x. I've done step 3 up here, I've eliminated the number, or it might be, in this case, it is a coefficient, but down below it's going to be a constant. So I've eliminated the number on the same side of the equation as the variable by using that inverse operation. I've eliminated that number. All I have is that x. I did that on one singular side of the equation. You're going to see me quite often, I'm going to use a different color for this. You're going to see me quite often divide my equation in half. I'm going to draw that line down the middle. I took this half of the equation, 7 times x, I'm going to get rid of that 4 there, 7 times x, and I eliminated this number so that I got just x. I divided by 7. Well, remember, this value was equal to 21. So whatever I do on one side of the equation, I have to do on the other side. So I divided by 7 over here. I have to divide by 7 over here. 21 divided by 7. What is 21 divided by 7? Yeah, we get 3. So in this case, 1x is equal to 3. So you'll see me do a couple of things when I show my work. I draw this line down the equal sign to separate the two sides. That allows me to make sure that I am, in fact, doing the steps on both sides. Whatever you do to one side of the equation, you do to the other side. I will also draw lines across here. Kind of like when we were doing stacked addition, you used to draw the equals line. That's what I'm doing here. Here's my step, my one step. I divided both sides by 7. And then here's the equation I get from that. I could also write this as x equals 3. The 1 is implied. There's 1x here. And so we don't often write that 1 in front for the coefficient. So here's my answer. Most of us feel like, yay, I'm done. But I'm not. Here's the biggest thing. Notice there's a step 5. Check your answers. You need to check your answers. We are trying to figure out what x is equal to, so we're going to replace x into this equation. 7 times, I'm replacing or substituting my 3 in for x. We always want to take the time to substitute. This is where we can find our mistakes. So then I'm saying, does 7 times 3 equal 21? 7 times 3 does equal 21, and that means that I have both sides of my equation are equivalent. So I am saying that 7 times 3 is equal to 21. This whole value is 21. This value is 21. My answer is good. I have checked my answer. I'm ready to move on to the next question. So let's try this again. Like I said earlier, I am going to actually rewrite this equation. You are pretty much not going to see that division sign in equations. This is an outline of notes that I got, so I'm not sure why they did that. You're going to see it written like this. You're going to see it written like that. X divided by 5. Now I'm going to try to do my work in another color so that you can see my steps. So the first thing is identify the operation. What is happening? Well, what's happening is x is being divided by 5. X is being divided by 5. So the next question is, how do I undo the operation? We need to identify that inverse operation. So the inverse of division is what? The inverse of division is multiplication. So when I go to do this work, I am dividing my equation in half. I'm only looking, in fact, I'll cover this side up. I'm only looking at this side of the equation right now, x divided by 5. I'm going to use that inverse operation, multiplication, to multiply. Now we're writing things like fractions right now. I can just write a 5. The proper way to do this would be to write 5 over 1. If I wanted 5 wholes, that means I have 5 of one-size pieces, right? I've got 5 over 1. And what we did over here before, so like 5 divided by 5, 5 divided by 5 is 1. That is what cancels these out. That's how I'm eliminating the number. Because 5 divided by 5 is 1. And that leaves me with simply my x value. Now, this is part of why I like to use colors to solve equations, is notice on this side of my equation over here, there's work. I did something, there's pink colors over here. But on this side of the equation, I haven't done anything yet. It also helps me to see that I didn't divide by 5 over here, I multiplied, which means over here, even though 15 is divisible by 5, I want to do the same thing. I want to multiply, just like I did over here. Now, I don't have to write it as a fraction because 15 is not written as a fraction, so I can just leave it at that. So we're doing 15 times 5. What is 15 times 5? Well, if I were doing 15 times 5 in my head, I would break it up 10 times 5 for 50, and then the 5 times 5 for 25, and I would add that back together in my head to get 75. My x value is 75. Am I done? No, I'm not done. I need to check my answer. I need to go back and plug in my answer. So I'm replacing 75 where there was an x. So 75 divided by 5, and I want to know if that equals 15. Okay, that might mean off to the side, I have to set up my long division, 75 and 5. 5 goes into 7 once. For 5, subtract it to get 2, bring down the 5. 5 goes into 25, 5 times for 25. So 15. So 75 divided by 5 equals 15. That is what my other side equals. So my answer is good. You don't want to assume, oh, I already did the math, so I know that 75 divided by 5 is 15. We want to check our work. This is how you can check your own work. Make sure you've found your mistakes and fix them before actually having your final answer. Alrighty, let's try these bottom two here. These ones are going to be a little bit maybe easier because they are addition and subtraction. So I split my equation in half. I'm only looking at this half. And I'm going to kind of draw a line across here so that you can separate those two. There we go. We're not looking at anything else above that blue line. So 4 plus a number is equal to 30. We're going to say 4 plus a number. I want to eliminate that number. I've identified the operation as 4 being added to a number. The inverse operation of addition is subtraction. So I'm going to subtract 4. What is 4 minus 4? Yeah, it's 0. 0 plus x is the same thing as just an x, and that's what we want. We want to know what x is equal to. So notice I've done something on one side. I have not yet done that on the other side. So I need to come over to this side, and I subtracted 4 over here. I need to subtract 4 on this side. So 30 minus 4 is equal to what? Yeah, 26. So again, some of you guys might be able to look at this equation and say, I already know that 4 plus 26 is 30. I can come up with that fact in my head. Fantastic. Now you're going to show your work, because we're going to get to way more complicated of problems, and we need to be able to show our work, and we need to be able to express our thinking on paper. So again, I'm not done. I have to check my answer. So 4 plus, I got to plug in my value for x, which was 26. Is that equal to 30 is the question. So I'm only looking at this one side. So 4 plus 26, that is 30. Is that what our other side was? Yes, it is. So we're taking the time to show our work and check our work. If you are not showing your work and checking your work, you won't be getting the full points there. So keep that in mind. We gotta do both. Alrighty, let's take a look at this last one here. We're separating that out. X minus 9. So when I say what's happening here, when you're identifying that operation, what's happening, we say that we have a number x, and we're subtracting 9. 9 is being subtracted from x. That's what's happening. So we're using subtraction. How do we undo subtraction? What's the inverse operation? It is addition. So we have minus 9 plus 9. That's going to equal 0. Remember, x plus or minus 0 is still x, and that's what we want. So you don't have to write this step in here, but you want to remember that when we're adding or subtracting, we're trying to make that 0 value so that we just have the x. I've eliminated the number. I got x by itself, but I haven't done anything to the other side yet. Whatever you do on one side, you have to do to the other side, because we have to keep it balanced. So plus 9, 3 plus 9 is equal to 12. So again, we can't just trust our answer. We have to plug it back in. So 12 was my x, minus 9. It's supposed to equal 3. Let's see. 12 minus 9. Well, you can count on a number line if you want to check that out, but 12 minus 9, we do get the value of 3. That is what our other side is. We put a check mark. Yes, we have the right answer. So, last things I'm going to leave you with. I apologize. I know this was a long one. I wanted to make sure, a long video. I want to make sure you understand the steps to follow. What's happening? How do I undo the operation? You have to do it on both sides. Whatever you do on one side, you have to do to the other side. And you have to check your answer. So it's really, really important that we show our work. If you don't like how this work is being shown, then you can talk with your teacher and we can help you come up with another way to show your work. But it has to have the two parts. It has to show how to solve it, and it has to show that you're checking your answer.